Welcome everybody. So this fun with vellum, we will just go through how we can create this multiple balls or soccer ball that's hitting this net as a vellum object and bouncing back of it. So we will focus on how we can come up with this net, how we can create this ball from nothing and making them ignite or run from different position, see, randomly. And there's a couple of things to be fixed, but I didn't run with high sub steps just to render it out, and I'm using redshift to render this one out. Very nice cloud. Okay, so let's head up to the first thing. We will import the geometry. So this is we have two geometry. First we have the scene, transport, merge size, so Ctrl G. So this is the whole field, soccer field. We go up and make normal lighting and no UV. Okay, so here it is, and we select Ctrl G. We select one of the goals, this one. After that I deleted it just to keep the side where the balls will be at, blast, and keeping this net. And this is a high res geometry, see. So what I come up with, I shrink it, convert it to lines, as you can see here. After that I shrink grab it, so I have the approximation of the geometry. Then I selected the faces I am in that represent the net. Okay, I give it pricker polygon divider, so I have the same representation, sort of assembly, and I call it a group of a net, and I run it as a cloth. So I'm not doing the lines, I'm doing the whole body cloth, and then I give it also attach it to the geometry, which is the frame, that is the wall, the frame of the goal. After that I'm giving it a glue, so the glue will make it attached to each other. See, it will look like one, and I import it to the solver. Here I went inside with it. You can do it as outside, but I do it as inside. So this is where the geometry running. Couple of cameras and dome light, redshift. The balls now. The balls I start here. Let's make it smaller. Ctrl G. I have a couple of balls I was choosing from. So this is American football. This is basketball. Different kind of football and tennis ball. So the one I'm using is this one. I give it a group. This one I ended up using only one just for speed. Okay, and I export them out so I can import them back again in here. So now this is the importing. Now we will prepare the model. To prepare the model. Where the model here, let's start with this one. This is the first model. Already we have the group, so it's pointless to have this one. I fuse it because it's multiple parts, so each one is alone. And the way we make it ignite, so see, we have this grid that will spark. So we scatter points. We have some normal, so it will be point to this side, and we are scattering points. And the way we are scattering points, If you can see, let's put it here. Here, see, it's coming and going. So the code we use here is the module of frame every 15 frame. If it's 0, soon it will give us 1 point. If not, it will not give us. And here I'm scattering only 1 point. So 1 point each time it is true. Global seed just to make it variance from the others. But I ended up using only 1. Then I copy the ball to the points. So I give it a color just. No, I didn't give it a color. So if you can see here, see, it's coming. So we have it as a copy points. We added a velocity that's targeting the net, and then here I used the cloth for the ball when it appear and a glue to connect its faces. And I'm outputting football, and so this is the setup of the vellum. The other two balls I use the same thing, vellum, and I'm outputting. This is the geometry, and this is the constraint. So let's find a frame here. Ctrl G. So these are the constraints, and this is the geometry. Let's remove the normal. So after we prepare our vellum, the net, the balls, everything, I go here to the DOP network. So now we'll talk about the vellum solver. Inside, a couple of things. Let's just please go back. I have my gravity. I have the static object that is a wall that represents the fence and the net. The bars. This is the vellum object, the ground, and this is the net. We are importing it. So we are using vellum source. Here I have the first ball, and I'm sourcing that ball. And here are the other two balls, but I ended up not using them. I went with 2 step and 20 constraint, and the second order. So let's make it run. Let's visualize here the first one. So it is coming randomly. This is an example. The more sub-step, the better the simulation will be in the reaction. Okay. Then we need to import the simulation after we finish the simulation, and we need to cache it also. So I go up 1 level, I cache it here. And here I'm blasting according to the group that we have. So this is the net, as you can see. I'm converting it back to lines, so I'm getting rid of the primitive. In this line I'm just running a polywire and getting back my what we call it. So we are having back our net. Here I'm blasting the ball. So this is the ball net, and to save its shape, I'm running it with this one post process. So I'm welding it and giving it some subdivision, adding a wrist length, wrist position, and point deforming, so I'm having the proper presentation of the geometry, and I'm merging all together here. So let's put this this camera. Here in the material, couple of material, all of them for the balls. This is the ground just a texture for the field, and this is the first football, just a texture. I'm applying it to this material without reflectivity, and in the output I'm fetching the vellum import. So, and I'm making sure with the batch node that always to make the whole frame range to be captured before you are running the redshift. So let's go to one of the frames. So imported the same, and now redshift render. So this is the redshift render. We have the frame range. The other thing I did also here, turn off rendering to the M-play, and here to make it all run, I'm unchecking the non-blocking current frame render. So all of them will sequence when we do the control, that frame by frame they will all run. If we didn't check this one, it will not do it. Cancel. So let's choose one of the cameras and make it run. Kick in. So this is the one. Let's choose another camera. Third camera. So this is the simulation. Thank you for watching. Have a nice